Okay, so then what we know is first thing is HCl is a covalent compound. HCl is a covalent compound, which means HCl is found by mixing one non-metallic atom with another non-metallic atom. Like for example, hydrogen and chlorine, these two are non-metals, and when non-metals and non-metal react, यिनीहरुले जहिले covalent bond form गर्छ, right? So then we studied the different methods of preparation of hydrogen chloride gas. So how can we prepare HCl gas? By different methods. So first method that we did was direct combination. Direct combination or direct synthesis. It's very simple, where we just combine hydrogen molecule with chlorine molecule in the presence of diffuse sunlight. So this reaction is carried forward only in diffuse sunlight. Diffuse sunlight like shady region, diffuse sunlight is important, not direct sunlight, diffuse sunlight. So for that, because in direct sunlight, this reaction gets very explosive and violent. So what we do is we react hydrogen and chlorine molecules in presence of diffused sunlight to form hydrogen chloride gas, right? So we don't use direct sunlight because this reaction is very, very explosive. Okay. And the second method is preparation. Second method is what is this called? Reaction of sodium, like metallic chlorides with acids. So we can prepare hydrogen chloride gas by reacting metal chlorides with acids like sulfuric acid. Your reaction by heating metallic chlorides with concentrated sulfuric acid. This thing was discussed clearly in the actual class. NaCl plus H2SO4 gives you NaHSO4 plus HCl. So यो दुईटा कन्डिसन चाहिँ याद गर्नुपर्छ हामीले. कुन केसमा चाहिँ NaHSO4 बनिन्छ र कुन केसमा चाहिँ Na2SO4 बनिन्छ, right? So this is acid salt. NaHSO4 भएको चाहिँ Na2SO4 is the normal salt, right? So the temperature less than 200 we get an acid salt and HCl gas. When the temperature is above 200 degrees Celsius, we get normal salt and HCl gas. Okay, so this method is also very, very important. यहाँ चाहिँ हामी metal chlorides like sodium chloride, potassium chloride, calcium chloride, copper chloride, यिनीहरुलाई react गर्छ with concentrated sulfuric acid. So when we react this with concentrated sulfuric acid, there are two possibilities that can be formed, right? Two possibilities. First one is an acid salt, and second one is a normal salt. So acid salt त्यो केसमा बनिन्छ जब temperature less than 200 हुन्छ, अनि normal salt त्यो केसमा बनिन्छ जब temperature greater than 200 छ. So यो दुईटा key terms चाहिँ याद गर्नुपर्छ तिमीहरुले यो. And one more thing you need to know is acid salt. यस्तो NaHSO4 जस्तो acid salt चाहिँ valency 2 भएको मेटलमा बनिदैन. So if for example copper chloride लाई मैले यो third reaction मा copper chloride लाई sulfuric acid सँग react गर्दैछु म. I'm reacting copper chloride with sulfuric acid, right? So यो केसमा चाहिँ हाम्रो एसिड सल्ट बनिदैन. यो केसमा चाहिँ खाली नर्मल सल्ट मात्रै बनिन्छ जुनै पनि टेम्परेचरमा, किनभने कपरको भ्यालेन्सी 2 हो, सल्फेटको भ्यालेन्सी 2 हो. सो देयर इज नो वे दैट वी कैन पुट अ हाइड्रोजन इन बिट्विन देम. सो हाइड्रोजन हाल्ने बित्तिकै भ्यालेन्सी 3 भइहाल्छ, व्हिच विल नट बी ब्यालेन्स्ड अन आइदर साइड. कपरको पनि ब्यालेन्स हुँदैन 3 भ्यालेन्सीले, सल्फेट पनि ब्यालेन्स हुँदैन 3 भ्यालेन्सीले. सो normal salt and acid salt is only produced only and only if the salt is from a metal whose valency is 1. So NaCl, KCl हरू छ भने मात्रै हाम्रो acid salt बनिने chances हुन्छ. जुन metal को valency 2 छ जस्तै copper, magnesium, calcium, यिनीहरुले acid salt बनाउँदैन. यिनीहरुले NaHSO4 बनाउँदैन या त CaHSO4 बनाउँदैन, CuHSO4 बनाउँदैन, किनभने यिनीहरुको valency already satisfied हुन्छ. सल्फेट को भ्यालेन्सी अलरेडी 2 हुन्छ, त्यहाँदेखि कपर या त त्यो मेटलको त्यो पर्टिकुलर मेटलको पनि भ्यालेन्सी 2 भइहाल्छ. सो त्यो पोसिबल हुँदैन. सो यो चीज याद गर्नुपर्छ. भ्यालेन्सी 1 भएको मेटल क्लोराइड्सले मात्रै एसिड सल्ट बनाउँछ, अरूले एसिड सल्ट बनाउँदैन. ओके, देन नेक्स्ट टपिक. Okay, next topic is laboratory preparation of hydrogen chloride gas. So in the laboratory, we do the same reaction what we saw just now. By heating metallic chlorides with concentrated sulfuric acid. But the only difference is we have some laboratory procedures. There is like a fixed apparatus where we work with, and by using the apparatus in the right way, we get HCl gas in the proper amount and proper concentration what we want. Right, so it should be very clear that hydrogen chloride gas is heavier than air. Okay, it is heavier than air. So if you if you mix hydrogen chloride gas with air, obviously the hydrogen chloride gas will settle downwards and air will go upward because HCl is heavier, so it'll come down, air will go up, right? So in the laboratory, the same reaction is carried forward. The same NaCl plus H2SO4 gives NaHSO4 plus HCl, same reaction, but like you can do with two different temperatures, right? So we do the same reaction here, but the apparatus is we have a round bottom flask, then त्यसको माथि एउटा थिसल फनल राखेको हुन्छ, त्यो थिसल फनलमा चाहिँ हामी सल्फ्युरिक एसिड बिस्तारै ड्रप गर्छ. We drop the sulfuric acid slowly from the thistle funnel down to the NaCl, right? So NaCl भनेको त we know it is common salt, जुन हामीले salt खान्छ, त्यो saltलाई NaCl भन्छ, right? So that NaCl is here, right? This यो जुन round bottom flask को मुनिपट्टि छ, that is the So this thing, what you see here, this black, this small solid thing inside the flask, it is sodium chloride. So that is the salt what we consume, right? The salt that we consume is sodium chloride, and this thing is known as the thistle funnel, the one that is coming down like this, the inverted funnel type. So this is known as a thistle funnel. Thistle funnel ko opening pani सानो हुन्छ, ending pani सानो हुन्छ, so that backflow नहोस् भनेर. So backflow prevent गर्न, we have thistle funnel ko shape like this. Then there is another tube that goes directly into another beaker containing sulfuric acid, and here we see bubbles here, right? And there is another tube that goes to a jar where the gas is collected by the upward displacement of air. So what we need to know is there are three stages. First stage is this stage, right? This exact stage, we react NaCl with concentrated sulfuric acid. So when we react that, HCl gas is liberated. We know clearly from the reaction that when we react NaCl with sulfuric acid, we get HCl gas. That is for sure. So हाम्रो यो ट्युबले चाहिँ this particular tube, यो horizontal ट्युबले चाहिँ HCl gas लादैछ यहाँ. But the HCl gas is not directly collected, but because यो ट्युबबाट आएको त HCl gas हो, we could have directly collected it, but we are not doing that. We are taking it to another jar containing concentrated sulfuric acid. अनि मैले यसको reason पनि भनेको थिएँ. HCl is bubbled through concentrated sulfuric acid because concentrated sulfuric acid is a drying agent, right? It is a drying agent, which means it soaks in all the excess water, all the extra water that is present in HCl. So if HCl has some content of water vapor or water in it, concentrated sulfuric acid will dissolve, will absorb all the water from HCl, and pure gas will be bubbled through HCl and will come out. It'll go through this tube and get collected by the upward displacement of air in this tube, right? So the reason why we pass HCl through concentrated sulfuric acid is because concentrated sulfuric acid is a good drying agent, right? It can dehydrate, it can remove water efficiently from HCl gas, right? So there are three stages. First one is the reaction stage. Then second stage is known as the drying stage, and third stage is known as the collecting stage. So reaction stage was NaCl plus H2SO4 concentrated will give you HCl gas, which goes through this tube to concentrated sulfuric acid beaker. Beaker ma concentrated sulfuric acid, right? And this second stage is known as the drying stage. HCl gas that comes through the tube is dried using concentrated sulfuric acid because concentrated sulfuric acid is a good drying agent. Then after that, the gas that is free from water is bubbled through H2SO4, and it comes out and goes through the tube and gets collected in the collecting stage by the upward displacement of air. Why is it upward displacement of air? Because HCl is heavier than air, right? It is a lot heavier than air. So the gas settles down, air goes up. So HCl gas is heavier, so it will go down gradually. And air, which is lighter than HCl, will slightly move upwards. So it is collected by the upward displacement of air. So this is the processes that you need to know while studying this part of the chapter. Then there is one more thing you need to know is why is phosphorus pentoxide or quicklime. So these two are also drying agents. Phosphorus pentoxide and quicklime, these are also drying agents. But what is the reason that we do not use these drying agents and prefer concentrated sulfuric acid over them? This is solely because HCl gas can readily react with these drying agents. So agar maile HCl gas like if I pass through phosphorus pentoxide, I'll not get HCl gas at the output. So my main concern is I should put HCl in the drying agent. The drying agent needs to only take the water vapor that is coming with the HCl gas. Okay, it should just remove the water content from the HCl gas. But the problem is if we use drying agents like phosphorus pentoxide and quicklime, they readily react with the HCl gas to form something else which we do not want, right? We do not want POCl3, we do not want HPO3. So this is not what we want. As a laboratory preparation process, we want the gas, purely the gas only. So we don't want anything else. So this reaction is not this drying agent is not a viable drying agent because it reacts with HCl gas readily to form something else that we do not want. Or same thing for calcium oxide or quicklime. So quicklime reacts with HCl to form calcium chloride and water. So we don't need calcium chloride right now. We are in the laboratory preparation of HCl. So we would want HCl as the output, but they react readily with HCl gas to form something else which we do not want. So calcium oxide, quicklime, or phosphorus pentoxide is not used as the drying agents for drying HCl gas, okay, because they readily react with HCl gas. The next thing is identification. I had already told you about this. How will you identify that you have a jar containing HCl gas? So if you have a jar and someone says that it is filled with certain gas, and you need to identify it. So when you open the lid of the jar, you see white colored fumes coming out of the jar. So this basically means that the jar contains HCl gas, because the HCl gas readily reacts with atmospheric moisture, atmospheric water or water vapor, whatever it is, to form atmospheric water vapor to form HCl acid, hydrochloric acid, which gives dense white fumes. So when you open the lid of HCl gas, it'll give dense white fumes of hydrochloric acid. Okay. So one more thing, after that we have how will we prepare HCl acid, hydrochloric acid? Prepare so that is just by mixing hydrogen chloride gas with water. But there is an inverted funnel experiment that I want you guys to study by yourself. So I don't know where that experiment is, but I think I have it in this book. This one, hydrochloric acid, laboratory method of preparation of hydrochloric acid. So I want you guys to read this by yourself. Laboratory method of preparation of hydrochloric acid. And one more topic is there. Why is the funnel arrangement used? So why we have an inverted funnel arrangement like this? We keep we pass HCl gas through this place, through this tube, and to this funnel, and the funnel is placed inverted inside, like on the surface of water. So why do we do that? So that is also provided in the book. So I want you guys to remember, like, study this by yourself. Okay, I might ask in the next class. Then there is one experiment where it is proven that HCl is heavier than air, or like we can also conclude from this experiment that HCl is not a supporter of combustion. HCl does not allow things to burn. So we have a tube that is shaped something like this. We have HCl gas in this end, then air inside the tube. So the candle is glowing right now. So when I open the lid, if I had a lid here and I opened the lid, and HCl gas would start flowing down. Since HCl is heavier than air, it'll go down, displace the air out. So air will go out, HCl will stay there. And since HCl is very bad, like it doesn't allow combustion to happen, it's not a supporter of combustion, the flame will go off, right? The candle will go off. So this is the very simple thing, very simple application way. There is a simple way to understand the concept. This is a very simple way to understand that HCl is heavier than air. Then we have the red fountain experiment. It's very, very simple. So we have a beaker containing blue litmus solution. So blue litmus is basically litmus turns blue only in basic solution. So we have a solution containing blue colored litmus with water. Okay. Then we have a tube that connects to inverted round bottom flask that is kept here, inverted round bottom flask. The inverted round bottom flask is corked. So it has a cork here, and the cork has two openings. So one opening is for this tube that goes directly from the blue litmus solution to the inverted round bottom flask. And the second opening is for the dropper. So dropper that can drop water in form of droplets, single drop, two drops, something like that. And this round bottom flask is filled with HCl gas. Okay, it is filled with HCl gas. Now, to start the experiment, I just squeeze the dropper. So this dropper, I just squeeze it 1 or 2 times to let the water go in. So the water that goes in reacts with HCl gas to form hydrochloric acid. At the same time, the blue litmus solution starts going up because of pressure difference. And it goes to it reaches a point where it comes in contact with the HCl acid that has already formed in the inverted round bottom flask, right? So it is here, and it is about to come out of the connector, the tube. But what happens is, the blue litmus solution will now be in contact with its hydrochloric acid that is formed by reacting HCl gas with the water that came out of the dropper. So the blue litmus now turns red, because blue litmus turns red in acidic solution, and HCl is a very strong acid. So the blue litmus fountain that comes out of the connecting tube looks red. It is red in color because the blue litmus turned red, because HCl is a very acidic, very, very strong acid, right? So HCl is a very strong acid. So from this experiment, you can draw 2 inferences. First inference is HCl gas is highly soluble in water. It is highly soluble in water. So just 2 droplets, 2 or 3 drops of water that came out from the dropper was enough to mix the entire HCl gas to form hydrochloric acid. And that hydrochloric acid turned the blue litmus solution red. And the red fountain is the HCl acid, hydrochloric acid, converting the blue litmus solution red. And the second inference is HCl is a very strong acid. HCl is a very strong acid because it readily turns blue litmus red. So these are the 2 inferences that you can draw from the inverted funnel what is this? The red fountain experiment. So this might come in the exam as a 4 marker. So not more than 4 mark. For maximum, it can come as a 3 marker as well, where you need to write a little bit about the experiment and you need to write the 2 inferences. So basically, this experiment has 1 inference, that is hydrochloric acid is a strong acid, so it turns blue litmus red. But if you also write that hydrogen chloride gas is very soluble in water, so that will be a plus point in your answer. So you need to note 2 different inferences for this experiment. HCl gas is highly soluble in water, and hydrochloric acid is a very strong acid. So these 2 things you need to know. Now there is one reaction that is very common with acids and metals. So the reaction, you have to know it by you need to know the concept as well. You need to know it by heart as well. So active metals. So these are basically active metals: sodium, calcium, magnesium, zinc, iron. These are all active metals. These are highly reactive metals, right? So these metals react with acid, hydrogen chloride gas or hydrochloric acid, whatever it is. It can react with hydrogen chloride gas or hydrochloric acid, both, to form salt and hydrogen gas. So active metals react with acids like hydrochloric acid or gas, hydrogen chloride gas, to form salt. NaCl is salt and hydrogen gas. This is a very, very important concept. Active metals react with acids, hydrochloric acid, or hydrogen chloride gas to form salt and hydrogen gas. Very simple, very important. So every time an active metal reacts with an acid, hydrochloric acid or hydrogen chloride gas, hydrogen gas is evolved. Hydrogen gas comes out as a result, right? So this thing you need to know. Then there are a few chemical properties that you need to know. I'll go through it once. This is all done by me, so I'm just revising it. Action with metals. So same reaction is done again. So metals react with hydrochloric acid. Metals react with hydrochloric acid to form salt and hydrogen gas. It's very simple. Action with oxides and hydroxides. So when some metal oxides react with acid, metal oxides react with acid, it forms salt, and now not hydrogen, now water is evolved. So some metal hydroxides like sodium hydroxides react with HCl to form sodium chloride, that is salt, and water H2. So there's also another important property. So metal with acid will give you hydrogen. Metal oxides with acid will give you water. That thing you need to know. Then we have with salts of weaker acids. So we know that what happens, we all know when an acid reacts with carbonate salts of metal or bicarbonate salts of metal, carbon dioxide and water is liberated every time carbon dioxide and water is liberated. When acid reacts with sulfides and bisulfides, sulfur dioxide and water is liberated. When acids react with sulfides, sodium sulfide or iron sulfide, or rotten egg smelling gas is liberated, and that gas is known as hydrogen sulfide gas. So all these reactions have been done. So you just need to check your notes once. So bicarbonates will give you carbon dioxide, water. Sulfides, bisulfides will give you sulfur dioxide and water. Sulfides, PHIDES, sulfides will give you hydrogen sulfide, which smells like rotten egg. Okay, so this is the thing you need to know. And there is one more reaction, that is oxidation of acid. Here it is, oxidation of hydrochloric acid. So oxidizing agents like manganese oxide, MnO2, PbO2, right? So these react with concentrated hydrochloric acid to form the metal salt, that is MnCl2, manganese chloride, plus water and a yellowish colored gas called chlorine. So this is oxidation of hydrochloric acid. So this reaction is also very important. Metal oxides like manganese oxide, lead oxide, this also lead oxide, I forgot its name. This KMnO4, this is potassium permanganate. So this fourth one, KMnO4, is known as potassium permanganate. This one is known as bleaching powder, yeah, COCl2. So metal oxides, oxidizing agents like this, these are all oxidizing agents: manganese oxide, lead oxide, potassium permanganate, bleaching powder, right? These are all oxidizing agents. These react with HCl to form salt. Salt is always there: CaCl2, MnCl2, PbCl2. Salt is always there. Water is also always there. So there is salt and water is constant, and there is a yellow colored gas that evolves and is known as chlorine. So when you oxidize hydrochloric acid, so hydrochloric acid like oxidize by using oxidizing agents like manganese oxide, lead oxide, potassium permanganate, bleaching powder. All these things, when you oxidize, you get a yellow colored gas coming, like evolving, and that yellow colored gas is known as chlorine, right? So it is yellow colored, pungent smelling gas. It's a irritating, it gives an irritating smell, irritating sensation, right? So this is done. So let's go for some ICSE questions here. I'll not solve them. I'll just aquaregia. I had done aquaregia. Where is aquaregia? Aquaregia is a mixture of 3 times concentrated HCl somewhere. Yeah, formation of aquaregia. Aquaregia is like 3 times concentrated HCl and one volume of HNO3 concentrated to give nitrosyl chloride, nascent chlorine, and H2O. So this aquaregia, you need to know this reaction. You have to know this by heart, okay? Your aquaregia is sure author. You have to remember this. 3 volume of concentrated HCl plus 1 volume of concentrated nitric acid gives you aquaregia. That is basically nitrosyl chloride and nascent chlorine. So now there are a lot of ICSE questions now. So write a balance equation for copper oxide and dilute hydrochloric acid. So copper oxide is not an oxidizing agent. So copper oxide, the hydrochloric acid react, we get copper chloride. So I think it's there in the book. Just open your book. I'll just write the answer for you. I'll solve for you. Okay, so this first reaction, right? Balance equation for copper oxide and dilute hydrochloric acid is there in the first part. Metal oxide HCl react salt or water that is there. Manganese oxide and concentrated hydrochloric acid. This is the last one. Manganese oxide is a what is that? It is an oxidizing agent. So this reaction. So यसरी confused गर्न दिन्छ. These two are metal oxides only, but they'll have different reaction. Copper oxide different parallel react गर्छ. Copper oxide different parallel HCl सँग react गर्छ. Manganese oxide different parallel गर्छ. You need to know. Name the experiment illustrated below. It's very simple. It is the, what is this? There is a red fountain experiment. Which property of hydrogen chloride is demonstrated by this experiment? There are two properties. First one is HCl is soluble in water. Second one is HCl is a very strong acid. State the color of water that has entered the round bottom flask. So what is the color of water that has entered the round bottom flask? What will the color? Can anyone type it to me? What will be the color of the water that has entered the round bottom flask? So what color of water is entering the round bottom flask? So that is the question. Chat ma bhanda ni huncha, yeah, you can turn on your mic and just tell me. So kun color चाहिँ यो फ्लास्कमा जाँदैछ भन्दैछ. Kun color of water is going into the flask? That is the question. So the answer is blue, because blue colored water is going from this flask to this. Only when it comes out of the connecting tube, it becomes red. So what color of water that has entered the color of water that entered the round bottom flask is basically blue only, but only after it comes out of the connecting tube, it becomes red. So these are very simple questions. Write balance equation, zinc and dilute hydrochloric acid. So this is there. Metal with hydrochloric acid gives you salt and hydrogen gas. So this is very simple. Calcium bicarbonate and dilute hydrochloric acid. Even simple. Carbon dioxide or water niskins with a salt. State what is observed when hydrochloric acid is added to silver nitrate solution. So you get a precipitate of AgCl. Even मैले पढाएको थिएँ, white color precipitate of AgCl. Where is it? I'll show you. Yeah, this one. Reaction with nitrates. It reacts with silver nitrate to form a white precipitate is insoluble in nitric acid, but soluble. So a white precipitate of AgCl is formed. So when silver nitrate is reacted with hydrochloric acid, a white precipitate of silver chloride is formed. Okay. So essentially you can solve this entire thing. If you read the chapter well, you can solve the entire ICSE questions easily. Your chapter ekdam simple. There is no application based questions, just straightforward questions from whatever you study from the book. If you don't study the book, you'll not be able to answer anything. So मैले यो video record गरेको छु. So I'll send the link of the video. If you want to refer to this chapter again, if you want to listen to the revision once again, you can go. I'll give you the link. Just check it out there. Okay. So if you have any doubts, you can let me right now. If you have any doubts, let me know. If you don't have any doubts, you can leave. Okay. I'll send you the link of the video after uploading it. If you have doubts, you can just raise your hand, else you can leave.